The Carnot cycle is one of the first thermodynamic cycles invented. The Carnot cycle, however, is only a theoretical idea because it relies on the concept of perfect efficiency. The concept of perfect efficiency is flawed because there will always be some sort of energy loss. The basic idea around the Carnot cycle is there is some sort of engine between two different heat reservoirs, a hot one and a cold one. Measuring the work done across the system is done by finding the energy difference between the hot and cold reservoir. The Carnot cycle achieves maximum efficiency because all the heat is added to the working fluid at the maximum temperature. The Rankine cycle is comprised of a pump, boiler, turbine, and condenser. The first stage of the cycle involves pumping water into the system. The water heats inside the boiler until it is transformed into steam. Then the steam runs through a turbine to harvest the energy from the steam. Finally, water cools down via a condenser and returns to the pump stage. This cycle is fairly efficient, however, it usually involves some sort of burnable fuel to heat the water to steam effectively. Among other advantages, this prevents the vapor from condensing during its expansion and thereby reducing the damage in the turbine blades, and improves the efficiency of the cycle because more of the heat flow into the cycle occurs at higher temperature. The Brayton cycle uses air as the working fluid in the system. It comprises a compressor, combustion chamber, and a turbine as the main elements. The air used can either come from fresh outside air or recycled air from the cycle. The compressor compresses the air and sends it into a combustion chamber. The combustion chamber heats the air and pushes it into a turbine. Finally, the air goes through the turbine and out of the system or back into it. Because this process doesn't use water that only water, the only requirement to run it is some sort of fuel. This process is widely versatile and seen in many industries including the airplane industry. A Brayton cycle for a gas turbine is a more efficient heat engine than the Rankine cycle used in a boiler. A combined cycle is the combination of Brayton cycle and the Rankine cycle. It is used widely throughout the world on many different power plants. The cycle harvests heat from the Brayton cycle at the end of it and uses a heat exchanger to boil the water for the Rankine. Because of the heat exchange process in the system, the entire combined cycle is massively efficient, essentially only having to use fuel in one spot to power two turbines. The Otto cycle is the process that shows a traditional spark ignition engine. The cycle comprises of piston cylinder stages. The first stage, known as the intake stroke, allows the fuel and air mixture to enter the system. Next, compressing the mixture in the compression stroke, then exploding the mixture in the ignition stroke. Finally is the expansion stroke, where the cylinder expands out all the way, which also includes the exhaust process. Physically, manifestations of the Otto cycle include internal combustion engines and reciprocating compressors. The diesel cycle is similar to the Otto cycle, however, it involves a higher compression ratio. The intake stroke in the diesel cycle does not include fuel. Fuel addition occurs through a fuel injector and combusts almost immediately due to the hot air inside the cylinder. This cycle uses different fuel sources than the Otto cycle because of the higher compression ratios. They are more rugged and reliable. There is no sparking as the fuel auto ignites. The absence of spark plugs or spark wires lowers maintenance cost. Fuel cost per kilowatt produced is 30 to 50% lower than the gas engines. The Stirling cycle is a variation of the Carnot cycle, but instead of the two isentropic processes, it contains two isochoric regeneration processes. The process is reversible, which is what differentiates it from the Otto and diesel cycles. Mechanical power may produce heating and cooling from this cycle. This cycle operates in many different stationary generators. because it runs quietly and minimal vibration. The main advantages of Stirling engines are the ability to use various heat sources and combustion chambers, meeting environmental requirements, a low level of noise and vibration, favorable characteristics for both vehicles and stationary electric generators, and a good consistency with a linear electric machine. Designed to remove heat from a system rather than adding it. The refrigeration cycle keeps enclosed spaces cold. The cycle works in reverse compared to others by rejecting the heat from the system rather than using the heat. Using a compressor, condenser, and an expansive valve, and evaporator, the cycle is able to effectively do this. It is traditional for the process working fluid to be a refrigerant like R134A because of its ability to remove heat effectively. Using other fluids is possible, however, many refrigerants present environmental and exposure risks.